used here, this one. In this model, we see that nt plus 1 is equal to nt and e raised to power r. Now you can see here why it is so. You can see here, replace t by t plus 1. You write this one, and then you have n0 e raised to power rt into e raised to power r. So n0 e raised to power rt is nt. So you'll get this one. So you get nt plus 1 is equal to nt e raised to power r. So e raised to power r is a factor which I am interested about. So let us say, for example, if I write, this is example. Let us say this I am writing nt plus 1 is equal to nt e raised to power r. Let us say, note that nt plus 1 is equal to 1.02 into nt. So it means e raised to power r is 1.02 in this. This is an example. This is an example. This means per year 2% increase is there per year. Since r is positive, so the population increases exponentially without limit. Now you see here, go to that model. So r is positive, and as t tends to infinity, this will be infinity. So again, population grows exponentially without any limit on it. So stability I cannot find. Thus, no stable equilibrium exists. The constant r is called the Malthusian constant. This word Malthusian is a renowned this biosciences scientist. Malthusian constant, you might have heard a Malthusian name, is a great botanist who started exploring how to find the size of the species. So this R he named as this R is named as against his name, Malthusian constant. So Malthusian is was a great botanist. So this R is designated as against his name, Malthusian constant. This model is appropriate to estimate R selected species. Now, what is that R selected species? So in life sciences, people or scientists have categorized the species into two categories. One is R selected species and other is K selected species. So this R selected species and K selected species. K selected species I will explain later. R selected species are those species in which all the individuals of the population, they live together, they eat together, they never fight with each other for resources. So only way of eating more is eat fast. They do not fight with each other like honeybees. They do not fight with each other for food. So only if they want to eat more, they have to eat fast. Similarly, pigeon population, sparrows population. So and then this termites, they never fight with each other for resources, for food. So this is R selected species. And I am a statistician. I know mathematics, I know statistics, but I don't know R selected species, K selected species. So this concept I learned from my fellow friends from in the university, botany department, geology department, literature, but is R selected, and through books I studied them. Otherwise, I can say I don't know R selected species, K selected species. So that is why nowadays interdisciplinary research is being promoted. So it is not that I'm doing pure mathematics and it is lying on the stacks. Nobody is using. So nowadays, government is saying all research organizations, they are saying that you go for interdisciplinary research so that some meaningful outcome is there. Now let us. So I told you the previous model is not giving me the stable equilibrium, but still that model works for certain species like honeybees, termites, and pigeon population. They grow very fast, right? But still I say that it is not giving me the stable equilibrium. And this model was the previous exponential model was applied to determine the elephant population. There, this model failed. That it gives infinite number of elephant population. So, which is never possible because they fight with each other for resources. Tiger population, they do not allow the others to eat more. So they fight with each other for their food. So it means this model does not work for those species. So then another modification can be thought of. We can also modify the above model by noticing that per capita growth rate decreases as the population size increases because of scarcity of the resources. Now, this concept comes from life sciences people, that when population size increases, we start using less, right? So if the population increases to a starts increasing to a very larger extent, then our resources are limited and we start consuming less. So it means per capita growth rate comes down or decreases as the population size increases because of limited available resources. So that this thing mathematically can brought here in the model, that we can describe it mathematically by writing left hand side is nothing, left hand side is per capita growth rate. So in the earlier model it was only R. Now I am decreasing it, right? Linearly decreasing. So minus C is a constant and NT. NT is the population size. So now you see here, if NT increases, this right hand side decreases linearly. So I am writing this one. So here C is some constant. I think this concept you must clear right now. I am saying that it should per capita growth rate, which is left hand side, it should decrease linearly as a function of population size, because population, I told you that as the population increases, the growth rate decreases by looking into the fact that the resources are limited. So you can say human being, our population is increasing and now many people have decided we will go for only one child. Some people are saying only two. So they know that it is very difficult to survive with large family size. So because our resources are limited, the expenses are involved, children education is there, so they decided. So I am saying it depends upon, because the resources are limited, so we have to rely only on the available resources. So this is linearly decreasing function of a population size. So now for stable equilibrium, the instantaneous per capita growth left hand side must be equal to 0. This gives it, I am saying stable equilibrium, the growth rate must be 0. So put left hand side equal to 0, I will get NT is equal to R over C. So this gives me the stable size. So remember this, when per capita growth rate is 0, so I get NT is equal to R over C. So this R over C is the size of the population which my system can sustain. So NT is equal to R over C. This constant, this R over C, called the carrying capacity of the system, is denoted by K. So carrying capacity of the system means system can sustain, or system will survive with only K population size. So this K, you can write K is equal to R over C. So writing K is equal to R over C, we get. So C you can find here. So you can write here. So remove C. C was the constant which I am saying here, this unknown constant. So I am solving this for C and putting this value here in the model. So the model is a function of now constant K and NT. And this R is per capita growth rate, which I considered in the model earlier. So now solve, this is again a differential equation. So use variable separation and method and simple jugglery. You can write here. For solving this differential equation, we can write this k dn, this one is equal to r dt, or this is equal to this. On now, you can use variable separation. You have already used that one. Use integration both sides. You will get log of this thing, log of nt over k minus nt. You know that if you differentiate this, you will get this one. So is equal to RT plus D, where D is again constant of integration, and this is equal to, you put R at T is equal to 0, you will get here left hand side log N0 K over N0 over K minus N0 is equal to D. So this is equal to this one, this D is equal to this one. You put that D value here and use this one. Simple mathematics, you can write nt over k minus nt is equal to this one. Now my aim is to solve this equation for nt only. So nt will be equal to the function of r and n0 and k. So that you have to solve. So this is equal to, finally you will get nt is equal to this one, k over 1 plus e raised to power 1 plus q into e raised to power minus rt, where q is equal to n0 this thing. This is called the logistic growth model. So this is very important model, logistic growth model. This model is used to predict k-selected species. What are those k-selected species? K-selected species are those species in which the strongest individual fills the needs first, and then if something is left over, then the weaker will start eating. So like tiger population, the strongest tiger will eat first, and once his needs are fulfilled, then he leaves that place, then the weaker one will start eating. So similarly, elephant population. So note that as t approaches to infinity and t tends to k, right here, as t tends to infinity, what is this? यहाँ लिखिए, as t tends to infinity, this will be equal to k over 1 plus this will be 0. So k over 1 is k, so nt is equal to k. So this is the stable equilibrium giving me that the largest population size is k, which the system can sustain, or with this k, the resources can be utilized properly. And if the population goes above k, immediately it comes back to k, and if it goes below k, it grows fast and attains the size k. So from equation star, this is the star, this one, we see that the that at equilibrium the left hand side is equal to 0 if nt is equal to 0 or nt is equal to p. You can see here, यहाँ देखिए. If you see here, this per capita growth rate left hand side is 0 in two situations. One is nt is equal to 0 or nt is equal to k. Note that nt is equal to 0 is unstable equilibrium. Why? Because we have never seen any population with the size 0. Maybe the species may be very rare, but 0 size is very unrealistic. So once its size is above 0, immediately it start producing more and more in order, because the our limited population size, resources are abundance, they use all the resources, foods, they grow very fast. Right, so this nt is equal to 0 is unstable. Why? Because once it goes above 0, it will start producing large and large, it never comes back to 0. That is why it is unstable. But nt is equal to k is a stable equilibrium. Because why it is stable? Because if the population size becomes more than k, the death rate increases at a faster rate, it comes back to k. If nt is less than k, then they grow very fast to attain the limit k. Now, in the above logistic growth model, we have assumed that the instantaneous growth rate is linearly decreasing. This one, linearly decreasing. This you see, per left hand side is per capita growth rate. It is linearly decreasing in NT. but sometimes it is not linearly decreasing. It is decreasing, but not linearly. Then the mathematician can think of some non-linear function also. So you can say the above logistic model, we have assumed that the instantaneous growth rate is linearly decreasing function of NT. If it is non-linear decreasing function of NT, then we can further improve it. One possible way is that, now I am saying it, if it is non-linearly decreasing, then it can be improved further by bringing into a function right hand side which is non-linearly decreasing. Now let us see what is that non-linear. One possible way, there are several ways. So one possible way I am introducing is that this decrease is proportional to log of fraction of carrying capacity utilized. What is this? This is NT is the current size at time t and K is the equilibrium size. So what is this? Fraction of carrying capacity. Total carrying capacity is K and this is being utilized. NT over K is the maximum. So NT is always less than or equal to K. So this is a fraction lying between 0 to 1. So this is, let us say this is 0.80. So it means 80% of the carrying capacity is used. If it is, this fraction is 0.9, then 90% carrying capacity is utilized. So I am saying a log of this fraction, and this is proportional to log of fraction of carrying capacity utilized with R as the constant of proportionality. R again, Malthusian constant will always remain as long as you are using per capita growth rate, that R is there. So thus we can write 1 over NT, left hand side is per capita growth rate is equal to minus R is the constant of proportionality, negative sign is for decrease, and log of fraction this carrying capacity. So minus sign is decrease, R is the constant, is saying proportional to. So R is the constant of proportionality, negative sign is for decrease. So use variable separation method, you will get this equation, and then on integration you get this one. So use this one. By using this, the initial boundary condition that we get d is equal to minus this of this, and then substituting the value of d here and use simple mathematical jugglery, you get this one. This is called the Gomper's growth curve. So those students who are studying or who have studied bit economics somewhere, they have they know the what are the growth curves. There are different growth curves: exponential growth curve, which I introduced, then linear growth, this Gomper's growth curve. They might have studied them. Now, question is how to find out K R, because they are not known to me. So what I do? How many unknown constants are there? K is unknown, and then N0 is that you have to explore, and R is unknown. So N0, I can get rid of N0. N0 say I can, there is no need to find N0. So my question is now, NT, I must know NT at different time points. Data I must have. So population size at year number 1, 2, 3, 4, 5, 6. So the more the data you have, better is the estimation of these constants K and R. Right? So let me go back to the simple one. This I'm writing this one, this model. This is the logistic growth model, which is the simplest one to explain that how to get rid of this one. Now, how to find out all these values. So what I do, somewhere you can write this Q is this one first. This Q is involved here. So either you know the initial time point population size, that you know that your starting year is the N0, then N1, N2, N3, N4, N5, that you have to determine. Let us say the population size in 2015, that is N0, population size in 16, that is N1, 17, 18, 19, 20. So these 6 values I have, right? So what I do, there are different methods. Either you have three, the number of unknowns are three. So you have 3 point population sizes are required. So you have three questions, three unknowns, solve them. So n1, n0, and sorry, n1 you have, n3 you have, n5 you have three unknown, three equations, solve them simultaneously. So this is way of solving them. There are different ways. Nowadays, many statistical packages are available. Only requirement is you should know the data at time points like T0, T1, T2, T3, and you have determined the population size at, against those points, and then you can estimate all these constants. Once you estimate these constants, substitute those values here, then this becomes your prediction model. So put T in this model, you will get the value of NT. So T may be future prediction. So for future, whatever T is, put that T value here, you will get the prediction of population size. So this is mathematical model I have established. I don't know K, I don't know Q, I don't know R, right? So for finding these three unknown constants, I need three equations. So you must know the population size at 3 time points, and then you will substitute those population sizes in this one. You will get three equations and solve them simultaneously. You know, mathematician can solve them and then find out those values. So with this, I think I must stop. So any discussion, queries, I welcome here. Let me stop sharing. Sorry. So anyway, I stopped sharing. Sorry. So any query, please? Any discussion?
So, any query, students, you want to ask any question, you can ask. It's
a very simple talk, but how to bring other information in mathematical form or sense.
So, talk is over?
Yeah, my talk is over now.
It's really interesting talk, sir. It's really honor to have you here. And I'm chasing you from last 2 months, and I'm able to get you. And I know that you are very busy, sir, having a 2-day meeting for IIT Ropar, the signing a memorandum of understanding. And really, sir, I'm really grateful to you. You have find a time and spared a time for this event. And students are really lucky that they have listened to you. I have heard your lecture, and that I was so much inspired. And I hope that so many students will get inspired from your lecture. And we are really thankful to you, sir, for your really interactive, interesting, engaging. And I have no objective for that. And the basic purpose of this DBT scheme is that we want to encourage our students by introducing them to a researcher like you. It's a really honor to have you here. I'm really thankful to you, sir. I'm also extending my gratitude to my principal, sir, for the visionary ideas and encouraging us. And the DBT coordinator, Dr.G.K, whose constant inspiration and efforts has given us the opportunity to hold such seminars, webinars, and so many activities. And I'm also thankful to my department and my HOD, sir. And any student you want to ask anything, you can ask.
Yes,
students,
I'm open.
If you have any queries and any member, faculty member want to ask something, they can ask.
Good morning, sir.
Please.
Hello, sir.
Sir, there is a request that you visit our institution. Principal sir also have given you invitation. So, sir, please visit our institution. We desperately want you here.
So actually, I am looking for these opportunities to interact with all young people. That is my now aim. After this retirement, I will keep on enlightening and talking to all young people. They should sometimes they are not happy with the system, but don't try to put blame on the system. So you have to build your system on your own, because teacher is a facilitator, and he can show you the path, but you have to walk on the path. We are showing you the path, that's all. So you have to run, you have to walk. Some people are slow learners, some people are fast learner, but ultimately slow learner, fast learner, if they keep on doing their work, they will reach the destination. Some people reach a bit early, some people reach the destination after a gap. But there is no saying that you will not reach the goal. Once you set the goal, you first set the goal. Goal should be very high, reasonable one, and try to explore how to reach that goal. And teacher can help you to reach that goal. You may be interested in sports, that facility a college is providing. You may be interested in humanity. You may be interested in sciences. That facility is there in all the colleges. Teachers are there. Excellent time, excellent books. You just see during my college days in 1972, I joined BSc in Degree College, Hamirpur, Himachal Pradesh. No teachers used to be there. No books in mathematics were available. Only hell books by R.K. Kohli, Bhallat, etc. They were available, and very complicated Punjab Publication Bureau books were introduced in mathematics, and that it was very difficult to digest those things. All basic mathematics was changed, Limit, continuity with different delta method, epsilon method of defining function that was introduced, and many teachers were not capable to teach, and that was the turning point. So earlier people used to solve differential equations, that was the and algebra, etc. But this calculus, differential equations, movement, etc. That those were introduced that time, and it was very difficult time. Teachers were not available. Only one teacher was there in mathematics. He was engaged with final year students, and by saying that first year, if there is repair, they have another year to go with, they can improve it, and let us hope another teacher joins. But nowadays situation has changed. All teachers are fully equipped. All are almost PhD or meritorious. They have come through their merit. So that problem is not there with you. Now only you have to set your goals and take the help of the teachers, take the help of your library in the but don't depend upon junk material available in the internet, right? So follow the textbooks. Whatever textbooks have been assigned to you, try to read them. I have seen many students, economics students, they in an interview, if I ask what is the definition of probability, they start beating the drum. Favorable cases over total cases. Which book you have read? I have read the from internet, that internet. This is not the proper definition. You go through the basic book and you'll see this definition works under certain assumptions, and they never read those assumptions. So read each and every line of your prescribed textbook. Don't say that only mathematics portion that you are writing and forget about the previous and next. What are the assumptions? Those assumptions, they are must. Similarly, in all the interviews I ask, basic mathematics. How do you define integration? What is its interpretation? When a function is said to be continuous, what are the requirements for a function to be integrable, etc. So all those, you always say integral, this equal to, what are the assumptions? What type of function it should be, so that integration is possible. Everybody knows integral of this function, you remember, you have done. But what is the requirement for a function to be integrable? You should know. Sometimes we ask that, find the integral of this function, but it is not integrable. People start thinking, oh, this is that one, but you should know, if some requirement is not met, basic assumption is not met, you cannot integrate it. Similarly, differentiation. Now you see your simple differentiation, that fundamental theorem of differential calculus. That is nothing but approximation to a function using its derivative, right? If you write f dash c is equal to divide by f of x plus h minus f of x divided by h, then you can see here f of x plus h is equal to f of x plus h times derivative of the function. This is nothing but approximation. Here in engineering, these people use a lot of mathematics, this approximation of a function in the neighborhood of a point. So because they want to find some change in the angle, so in making the rotation of the instrument. So a small fraction is useful for them to find out the proper rotation. So with this, I think I must stop. If you have any queries, students can ask me right now, or they can mail me. My mail was there. You can have my mail from Professor Gulshan also.
Nice talk, sir. Really limited resources can never stop you. The Ramanujan, we are celebrating the National Mathematics Day for Ramanujan. Ramanujan was also having a limited resources, but the will is there. So student,
Yes.
you need a willpower. If the teacher like A and Gill were there, then we definitely rise in life and really treat to listen to your lectures, sir. It's a really wonderful day. We have celebrated the Mathematics Day with you, and I hope that a lot of students will understand and they will enjoy their life. Thank you all. And really, especially, sir, I'm really thankful to you that you have taken a time from your busy schedule and you come here, and really we're thankful to you, sir. From the Department of Mathematics, I am really thankful to you.
Thank you, sir. Thank you. I'll definitely try to come in person and interact with your PG students.
Sir, one more thing, that we have established a lab, mathematics lab in our institution. With the institution, with the initiative of our principal, sir, we have a computational mathematics lab, and we want that the student learn projection statistics. So we need your help there. So I wish you come here and then you visit our lab also.
Definitely. I'll. Thank you very much. So nice of you.
Thank you, sir.
Remembering me, and I will definitely be a part of all educational institutions. Those who ask for my help, I will be there. I will spare my time this way or that way. I will be there.
Thank you all the lovely participants. You have taken your time and you have been so patient. I'm really thankful to you also. And now it's end from us, and happy Mathematics Day, and wish you a great day ahead.
Thank you.
Now over to Sakshi.
Thank you so much, Professor Amarnath Gill. We really appreciate your knowledge, sir. And last but not the least, I thank everyone being here, all the dignities, and the students of DOABA College for being a part of this event with all their sincerity. Thank you so much.
So thank you. Thanks a lot. And I have to leave now because there is some meeting going on. So thank you very much.